You always want the QI is this correct, is it correct? Okay. So now you can decide what do they want. For your QI is always in the range. So cross multiply, and then you have to either move your x and y to the other side. Okay. Okay. Now this cannot be moved. This is all connected, so now we have y over make this function. Okay. It's always good to just notice. What do you think? So we can walk into the rewrite that line from Stephen Lewis. The two fractions and the plus one. Okay. Yes, so figure out the rule for this time, figure out what you want to say. You can modify this, brings the top. There's something going on there. You can take a look. It's complicated down before the one. So it looks like these are together, essentially these are together, and that's so great. So we'll go through. So, yeah, it looks like it used to go to is basically the other defense. That's separate. So that's they keep their reflections. Yeah, we should be trying to think about that. So we have to actually it's without this is all that's what we're it's the practice sideways. So the one for the humans has to that one check that reader. Cross function. They can decide when the first one myself as a body surface of good. It's was the base. It's the beginnings and it's the next level. First, we would separate everything. It's the definition of so the systems are okay. Yeah, walking around, it's just it feels like you want to kind of force things algebraically. And I know some students saw this y prime there and they just feel like, oh, this xln(x) minus y must be together. So they end up moving that over to the other side. But algebraically, this y prime xln(x), this is connected. It's the y that's separate. So if we start off, we have to start off like this, right? Can't just move that x ln x along with that y because order of operations, that y is going to be the one that's separate. So now you can rewrite this as dy dx. I'm sorry. You can. I like to get my two fractions lined up nicely first so that I'm not making any mistakes. So I like to get my two fractions, a over b equals c over d, and then cross multiply, and then getting my dy dx's lined up. But if you choose to do a different way, just make sure that that we're in agreement. So that's the first step, right? Trying to get everything lined up. Remember, your dy dx's are always in the numerator. We never want to move those to the denominator. Those are your anchor variables. So you know that those two things are locked in place. If you want to move anything, you got to move things around it. So after this point, do we have full separation variables? No. X ln x out of place. Y is out of place as well. So what can we do to get them both into their right places? Divide. So where are they going to end up? Denominator. So they're both going to end up in the denominator on the other side, right? So I know students feel a little uncertain about the situation. They see everything in the denominator, but just keep in mind that your things are in the right place if your dy dx's are up top, right? And it's okay to have your y and x's in the denominator. Now, if your dy dx's end up in the denominator, that's off. Okay, so we want to make sure that it's okay to have those x's and y's in the denominator. There are rules that can handle them, but your dy dx's need to be up top. Okay, so now we have full separation of variables. We can now take the antiderivative, go through our calculus step. Left side is just what? Natural log. But the right side's a little complicated here, so we got to go through what? U substitution. What's our u value? Natural log of x. Remember, your u value is always more than just an x. If you only do a one-for-one substitution, you're rewriting the problem, but you're not making the problem look any different. Okay. What's natural log's derivative? U prime over u, right? So 1 over x, cross multiply. Make your substitutions that we've underlined. Cross out the x's. Now we're left with 1 over u du. So we have natural log now on both sides. Let me reset here. So left side is 1 over y dy. Right side is 1 over u du. Okay, so we said natural log on both sides, right? So natural log absolute value of y, natural log absolute value of u plus what? C. And then this side, we went through your substitutions. So we got to bring back our x on the right side. So natural log of what? Absolute value of natural log of x. Okay, so it looks like both sides. It's that left side that we really care about getting down to y, right? The right side is whatever ends up. We can leave it in that form, but the left side is really why we want to take that, raise both sides with base e so that we can get down to that y. So raise both sides with e as the base. We know the left side cleans up to be just absolute value of y. Now the right side, we're going to take advantage of this property here. A to the m plus n is equal to a to the m times a to the n. So if I understand my m plus n are the exponents, I can separate into the product of two bases. So it's going to be e to the natural log of x. what? What's the next operation? Not plus, by the way, times e to the c. Now we know e to the c is just one big constant that's being now multiplied. And then we see some cleanup. This looks messy, but we can actually clean this up here. This actually cleans up to be just what? Yeah, because we know e in natural log, that's a nice canceling out relationship there. So absolute value of natural log of x. I can drag the c out in front. I can drop both sets of absolute values because they're both going to produce plus or minuses, and the c's will take in all the plus or minus in the equation. And now we're ready for the order pair, right? So order pair is e comma e. E in for x, e in for y. What's the natural log of e going to be? It's 1. Yeah. So e is equal to c times 1. So c equals e. So now we just put that e back into our general equation. So y is equal to e natural log of x.
It's about the C for D.
That's right. Yeah. So whenever we swap out the c with a number, we're changing our equation from a general to a particular.
Where did 1 over y come from? Operate. Over y.
Okay, right, 1 over y. So that I just rearranged it. I just pulled the dy to the right, and I just had a 1. I mean, you can leave it in this form. I just find that if I rearrange it, sometimes students feel like this feels more familiar, but these are the same thing, right? So I'm just pulling that y out in front. I mean, outside that fraction.
Do you make things simpler?
I'm sorry?
Do you make things simpler? You do it like that?
Oh, you think? Oh, you're asking if it makes it simpler?
Yeah.
No, I think if you jump from here to here, that's fine.
Okay.
But I just rewrote it and thinking that maybe some students would find it more familiar if I wrote it this way. Okay. All right, can we do one more? You guys have a blank page on page 22, right? Okay. Let me see how you guys do with this one. Okay, I know we're spending a lot of time on differential equations, but that is the bulk of the test. So, we are essentially doing test review as we're doing this.
New material, right?
Yeah, we're doing new material. Yeah, so your test will be solving differential equations, slow fields, inverse trig integrals, solving for y equals c e to the kt. I think we're pretty good with that, right? Creating all these order pairs and plugging in and solving for c, solving for k. I mean, we'll practice some today and next week, but this is really the most important thing, I think. Okay, the hint is, can you catch yourself avoiding a common mistake that many students make? Okay, so that's the hint. Substitution. There's only one variable here. These are all in place. Yeah, we'll start taking time. Yeah, but substitution is that's what you first, what second, so that they can go. This is that's this match. Left side of myself. How these are all different things this can do. The next. So we can't do see how it's not no force separation or so these are not going to move, get it moved next to last year. So you end up dividing dividing the levels, which you have these on there's a next way which was. Someone try that.
Oh, people don't use that they shoot my little, but you bring them up to the top, like on my.
And yes, it was. It's the last. I'll go to the thing of the field. Oh. So you see how you want the X to move over to this side? So if you end up moving it to this side, where's it gonna end up? Where's the best? This one. In the denominator, right? If you divide, and the y squared is gonna also end up with the denominator. I know a lot of students want to do this, they want to move it over to the side, they gotta divide. Okay, do this one.
So you, like, at some point, you making
You have to get it, so now you're ready for your. Right, when you see it. Substitution. What is on there? So you just put around this way. It's not that. Yeah, this, it's not really going to do something. But that's why they want to do that's like first as a practice. We got to go finish. Let me go to this. Yeah, this one feels a little unfamiliar because we just haven't seen problems like this, but I think it's good to kind of wrestle through this and try to figure that out. So. Okay, so dy dx, right? All right, cross multiply. Okay, so if we look, our dy dx's are in their right places. We're not going to move them, but we don't have force separation variables, right? X's and y has to move. They're both going to have to move to the other side, and we're going to have to divide. And if we divide something from the numerator, it's going to end up in the denominator on the other side. So they're both going to move. So we're going to end up with dy over y squared equals dx over x. Are we okay with that portion there? Okay, so now we have full separation, right? Full separation of variables. Right side is just what? This is just 1 over x dx, right? So what rule do we use there? Right, is this natural log 1 over x dx, integral 1 over x dx? This left side here, I think a lot of students were good not avoiding natural log, because this is not natural log, right? This is not y to the first power. But I see some students trying to go through use substitution. There's no need for use substitution when there's only one variable. Now, if it was like, 2y minus 1 squared, you have a set of parentheses, then I would go through use substitution. But this, no need for it. We just have to get that y in a different place. What rule do we use if it's not natural log? Yeah, power rule. We got to bring it to the top, right?
Keep the X below.
I'm sorry.
Keep the X below, like that.
This one here?
Yeah.
Yeah, because if we bring it up, remember 1 over x is the one case that power rule can't apply, because if I bring it up, I get x to -1. And if I try power rule with that, I get x to 0 over 0, and that's undefined. So 1 over x is natural log. Okay, so what's the rule for y to -2? It becomes what? Over -1 equals natural log absolute value of x plus c. So this is unfamiliar because we're used to just having that y by itself, but now it's going to be in the denominator here. So we're going to have to kind of play with that left side. But at least we're at the function level, right? So now it's just a matter of trying to get y by itself and solve for c, but it's going to feel a little strange here with that y being in the denominator because of negative exponent. So I'm going to rewrite it, make it -1 over y is equal to natural log absolute value of x plus c. So I want to solve for y, but one thing is I want to just go ahead and move that negative out of the way. So if I can just multiply everything through by -1. Are we good with this stuff here? Now we can cross multiply and eventually get y by itself, but I also want to show you something here. If we have a fraction equaling a fraction like this, I can flip the left side and flip the right side, and I can make everything balanced that way. So, I mean, that's the same thing as cross multiplying, eventually solving for y, but we can do this. I know it looks strange, but algebraically, we're still okay here. Okay, so this is our general equation. And now what can we do to solve for c? Plug in 1 and 2. Right? Right? What's natural log of 1? 0. So 2 is equal to 1 over c. So 2c equals 1. C equals 1/2. Yes, question.
Would be negative. Does that just go?
Yeah, well, the negative is outside. So, and the 1 is always positive. So it's natural log of 1, which is 0, and -0 is still going to be 0. Is that what you're asking? Or?
Yeah.
So C is 1/2. So once we have our C value, we're going to put it back where we made the substitution with our order pair. So our equation looks a little strange, but we haven't quite seen this form yet, but it's good for us to kind of try it on our own first to see how far we can get. So what I want to say is when you go through cross multiplying and trust that process, right? Trust that process of cross multiplying and trusting that the algebra will get you to where you want it to be. I see some students, they kind of have a picture in their mind of where they want the variables to be before they go through the algebra, and they end up forcing variables in places where the algebra doesn't support, and then you end up solving different problems. So just, I would say, really trust that process of cross multiplying. And as long as you know your dy dx are your anchor variables, then wherever your other variables end up, that's where they should be. Okay. Okay.
Let's see it.
Yeah, right here. Okay, let's go to our new packet here. Does anyone not have the new packet? Okay, I'm going to just pick and choose the ones that we really need to be able to do. So let's go to number 1. Oh yeah, yes. It's over there behind the top. There you go. So if we look at number 1 here, we're only going to do a portion of this here. It says find a particular solution. So we will go through the step, cross multiply, all that. I'm going to skip part A because we've been practicing a lot. Maybe we'll come back to it. We don't have to worry about domain. I want to focus on this part. We need to be able to do this as well. Okay. And this is find the equation of tangent line. This is going back to first semester. And typically with differential equation, FRQs, sometimes these are kind of tag-alongs with these differential equation problems. So I just want us to understand that this is a first semester problem. So find the equation of a tangent line. Okay, let's think about that. If I want to find equation of a tangent line, what information do I need to build that tangent line? Slope and points, right? And I have my points here. So how do I find my derivative? Good. So I know your dy dx looks different than first semester, but it's still dy dx. It's still y prime. It's still f prime. This is your slope formula. Sometimes you may be asked to go through your whole differential equation process, separating variables, all that. But other times you may just be asked to just pull the slope, like how we did first semester. Right? So once we pull the slope, we can take our order pair and our slope and then put it into point slope form. And that's our tangent line equation. Okay, so let's do that. So that means dy dx at -1, -2. So in this case, my derivative equation requires both the x and y value, but all I'm doing is just plugging in, and whatever I get back in return is my slope value. So what does that equal to? Dy dx equals -1/2, right? So what you guys got? Are we good there? All right, we're just inserting x and y into our derivative, getting our slope. So now that we have our slope, let's reset. We have our order pair. We have our slope. And now point slope form. Okay, that's first semester stuff, right? So just know when the problem is asking to solve a differential equation, but then also know when the problem is just asking for a tangent line equation. where you're not messing with your differential equation. All you need is to grab the slope from that derivative. So that's part C. Now part D, it says use this equation to approximate negative 1.1. So this is just asking, this is also first semester content, linear approximation. You guys remember, what do we do with linear approximation? It involves the decimal in this equation.
Usually a point. They got exported.
Even easier,
You plug it in.
even easier. You just plug it in. That's all we do, right? All we're doing is we're using a line to approximate a decimal, right? So I know it sounds really complicated, but you're just taking whatever decimal they give you, inserting into your equation, and you're done. So a lot of students make it more complicated or more difficult than it's supposed to be. It really is as easy as that, right? So whenever you're asking for linear approximation, it's usually paired with tangent line equation. Build that line, plug in the decimal, and then basically we just have to solve for y, get y by itself and get some decimal. Use our calculator to do the rest.
We let you type in the test.
Yeah.
So could you be going into? Yeah.
Into your linear equation.
So the 1/2, not the y+2.
Well, the negative 1.1 is an x value.
Okay.
I'm just inserting that in for the x. Right. You guys get negative 1.95. Let me double check that.
They just say it's not ratio, but they do say the change in the yes. Ratio is circular.
Yes, okay, thank you. Okay, let's do a y equals c to the kt problem. So let's go to page 3.
What's the graph word?
Yeah, we're not gonna, that's for slow fields, but on the test, you won't be creating one. Well, if you create one, it'll just be a few order pairs, like the next page, so it won't be one. Or there'll be a matching problem, but we'll deal with that Wednesday. Okay, let's do a y equals, this is page 3 here. Okay, oil is pumped continuously from a certain oil well at a rate proportional to the amount of oil left in the well. dy dt equals ky, where y is the amount of oil left in the well at any time t. Initially, there is 1 million gallons of oil. 6 years later, there's 500,000 remaining. Write an equation for y, the amount of oil remaining in the well at any time. So this is basically y prime equals ky. I mean, we can solve the differential equation, but do you guys remember what this turns into? Yeah, y equals ce to the kp. It could be p prime equals kp. It could be l prime equals kl. It could be r prime equals kr, right? Anything in that form, and we can, right, go through all the full calculus process, but we know it's just going to end up this. So basically no calculus effort needed because we already know where it's going to head, where it's going to be heading. Okay, so for part B, at what rate is the amount of oil in the well decreasing when there's 600,000 gallons of oil remaining? So this is the full process where we create our order pairs, right? One order pair will help us solve for C, another order pair will solve for K. We're going to update our equation, and then we can plug in that final set of information. So we know that with all these equations, there's always going to be time and something else. And then for oil, we're going to use the variable y here. So T for time, y for oil. So it says initially there's 1 million gallons of oil. So what order pair can we create there? Yep, 0, 1 million. I'm going to use both space here so we can not, so we feel like we have enough space for part B. So I'm just going to gather my information on the left side and just bleed into part B here. Six years later, 500,000 remaining. Was my second order pair. Yeah, 6, 500,000. And my third order pair, at what rate is the amount of oil in the well decreasing when there's 600,000 gallons of oil remaining? So it's going to be, yes, T, 600,000. So we're going to do that at the very end, right? We're not going to do that until we've used our first order pairs to build our equation. So we can skip a step here because this 0, 1 million is just going to basically be, that 1 million will just be the what? Yeah, the C value. I mean, we can go in and plug in the 0, we'll plug in for T, it'll wipe that out. Y is 1 million, so we can just update the equation. Okay, second order pair is we can update the that initial order pair with the C value, and then we can update our equation, and then plug in the second set of order pairs. So 6 can go in for T, and 500,000 goes in for Y. Okay, and then we can work towards solving for K. Okay, we want to solve for K, but let's move the easy things first. What can we do to move things away from that right side? Yeah, divide by a million, right? So 500,000 divided by a million is just what? 1/2 or 0.5. Okay, I want to solve for K, but K is stuck in the exponent, so take natural log. That exponent is now free to move down in front. Natural log of E is just 1. Divide both sides by 6. We have our K value, but hold on to it. Don't convert that to a decimal. We want to improve our accuracy for the end, so we're just holding on to that value. Okay. We can update our equation now with a specific K value. Can plug in 600,000 and solve for T. We're not going to do part C, so if you want to use part C to continue your work, you can. Yes.
What if you put the 6 on the bottom?
Oh, sorry, my bad. That's, I think I was ahead of myself there. Okay, so I'm going to write my updated equation. Now I can plug in 600,000 in for what? Y. And then I can work towards solving for T, right? So we can divide by a million, take the natural log of both sides, bring that exponent down, and then finished off the problem. Okay, we want to solve for t, but t is stuck in the exponent location, so we'll take the natural log of both sides. Bring that messiness down, and then we can eventually divide that over and solve for t.
Yeah, I just wanted to say.
Appreciate it.
I know. like,
Thank you
all
so
drawing.
much. Thank you.
You want me to make some more copies? No.
And the final step, divide both sides by natural log of 0.6 over 6. Use your calculator to do all that for us. Sorry, guys. For part B, we're solving a different question. I meant for part B to read what is the time when 600,000 gallons remains. So this, sorry, we're doing a different problem here. But we're going to just solve for t here. Okay, 4 equals 4.42 years. Okay, so we'll continue reviewing when we come back from break. So yeah, come get your phone. I'll send out a help session schedule Tuesday so that you know plan your week accordingly for the help sessions. P-value. Yeah, well, yeah, because we solved for the K, right? Yeah. K is the help with our.